Hi, this is Dr. V.S. Nishok, EC Department, SNS College of Technology. We have seen the introduction about the dynamic logic circuit in VLSI in our previous video. So there we have discussed the basic structure of dynamic logic circuit and several examples we have seen based on the dynamic logic circuit, and also we have seen the operations based on the pre-charge mode and evaluate mode. So if pre-charge mode, then the clock signal will be equal to 0, that is given to the PMOS and NMOS transistor, and the input variables will be given to the pull down network. Similarly, in the evaluate mode, we have seen that clock signal will be equal to 1 instead of 0, and the n number of inputs will be given to the pull down network. So this is mainly used for reduced transistors and for more cascaded circuits or complex circuits. So in this case, we are going to see what are the advantages and disadvantages around this dynamic logic circuit. So to design high speed cascade circuits, so more number of seriously connected transistors, see those complex circuits will be done with the help of this dynamic logic design. Okay, so here number of transistors are mentioned as n plus 2 transistors. N represents the pull down network, that is n number of input variables, and then 2 represents the 2 transistors that is connected with the clock input signal, that is one NMOS and one PMOS transistors. Here there is no static power dissipation through this dynamic logic circuits, which that is this type of static power dissipation is available only in the static CMOS design. Here there is no static power dissipation. So that is the main advantage of the dynamic logic circuit. And here clock signals are needed in this dynamic logic circuits, and we need to design it carefully. Coming to the disadvantages, we are having several disadvantages under this dynamic logic circuits. So that starts with charge leakage in between the path, and charge sharing in between the path, and cascading issue. So if we are cascading the more number of stages, then we will be having degraded output. So that is the main disadvantage of this dynamic logic circuit. And capacitive coupling and clock feed through and clock is mandatory. So these are all the several disadvantages comes under the category of dynamic logic circuits. So here in this diagram we can see the charge leakage. So that is leakage sources. So the small inverter circuit is given here. So A is nothing but the inverter input that is given to the pull down network, and phi represents the clock signal given to the PMOS transistor and the NMOS transistors. So if in case just we can see that when the clock signal is equal to 0, the NMOS transistor in the below the pull down network will be in the off condition, but the PMOS transistor will be in the on condition. So the VDD will flows through the PMOS transistor and reaches the output path, which makes the capacitor across the output path to glow. So in this case what happens? So in this case we are going for the evaluation mode. When clock signal equal to 1, there will be the flow of the voltage across the output path towards the ground based on the pull down network. If the pull down network equal to on, that is NMOS transistor in the pull down network is on, then every charge will flow towards the ground and output will be equal to 0. But in case that pull down network is equal to off, that is NMOS transistor in the pull down network equal to off, the charge in the output path will be leaked quietly or very little around the path in between the output path and the pull down network, and also in between the PMOS transistor and the output path. So these are all the main source where we are having the we can find the leakage of charges. So that degrades the output. So this is the main charge leakage issue here. And similarly, charge sharing also happens. Similarly, in the same scenario, in the that is evaluation mode, when the clock signal equal to 1 and when the clock signal equal to 1, the charge across the output path will be flowing towards the pull down network. So in this scenario, if you consider n number of input variables, so there, due to parasitic capacitances, the charge starts to shared from the output path. So due to that, there will be a degraded output. So that is also a main drawback here. And coming to the cascading issue, if this is a one stage and similarly n number of stages are connected, n number of this stages are connected, there due to the delay, that is due to the time taken by the charge in the output path to flow through the NMOS transistor towards the ground, due to that issue we are giving the wrong input, we will be giving the wrong input to the second stage. So that makes the degraded output in the future, that is further upcoming stages. So that is the main disadvantage of this dynamic logic. So this will be further overcome with the help of the domino logic. So the main disadvantage of the dynamic logic is nothing but the cascading issue. So that will be overcome with the help of the domino logic that comes under the same dynamic CMOS design. So here are some assessment questions for your understanding purpose. Okay, thank you. We can see in the next video.